Power and radical functions. The objective of this video is to graph and analyze radical functions. So first we want to recall what a power function is, and that is basically anything of the form ax to the power of n. A is just a coefficient and n is just any of the powers. An expression with rational exponents can be written in radical form. So if you encounter a rational exponent, meaning a exponent written with a fraction, then that's basically another form of writing radicals. For example, instead of having x, the square root of x, that is the same thing as saying your base is whatever is inside. 1 is whatever my base is being raised by, because there is no power in this case. There is an imaginary exponent of 1 over 2, because my square root symbol is the second root. If it were a third root or a fourth root, then my denominator would be those numbers. Also remember that a reciprocal function is of the form 1 over x, and another way of writing that in terms of exponents is with negative exponents. So x to the negative 1 power means 1 over x. This means that a negative power can lead to the restrictions in the domain, because remember, 0 can never be the bottom of a fraction. So in previous lessons, we have talked about the characteristics of functions such as the radical functions. We are able to find the domain and range, x and y intercepts. Remember, continuity is basically, are there any holes in the graph? And then we can discuss the end behavior, because we should be familiar with our parent functions. Some of our other characteristics of power functions, which we have discussed before, are also our parabolas, so our quadratics and our cubics, where we are able to identify end behavior, symmetry, domain and range, x and y intercepts, etc. So we should be very familiar with these functions without having to necessarily graph them, because we've seen them before. So the main objective of this video is to make sure that we can solve radical equations and functions and check for extraneous solutions. So our goal is going to be to isolate the radicals first by getting rid of the 14. So I'm just going to do minus 14 on both sides. So this leaves me with the cube root of x minus 5 raised to the second power. And then 50 minus 14 is 36. Now, because we have something raised to the being the third root of something, my goal is to isolate that by doing the opposite, by raising it to the third power. This will cancel out the root with the power, but remember, we have to do the same thing on both sides. So we are left with x minus 5. All of that is being squared. And then 36 to the third power, which is 46,656. We do want to take now the square root to get rid of the power. So we have to take the square root over here. Remember, we always have to have plus or minus when we are taking the square root. So we are left with x minus 5. And the square root of that number, which is 216. So now we just want to get x by itself, so we are going to add. Remember, because we have plus or minus 216, we're going to have two solutions. So x is equal to 216 plus 15 with plus 5, which is 221. And x is equal to negative 226 plus 5, which is negative 211. Now, because we ended up squaring, cubing, things, we want to make sure that we check for extraneous solutions. Extraneous solutions basically means that when we solve algebraically, it looks like we have two answers, but when we go back in and plug in our answers to check to see if the equations are true, one of the solutions or some of the solutions do not work. They do not create true equations. So we are going to have to check both of our solutions before we can say they are answers. So all that means is I took my two answers and I plugged it in 4x in my original equation. And now I'm going to simplify to see if in fact the left side is going to equal to 50. So in this case, both answers check out. They both equal 50. Therefore, the solution to the problem would be x equal to 221 and x equal to negative 211. So we solved the previous problem. Now you try and solve this problem on the right. Pause your video, see if you can figure it out, then press play to see if your answer is correct. Pause your video now. So I'm going to isolate my radical. So I'm left with cube root of 4x plus 8 equal to 4. Because it's the cube root, I'm going to raise everything to the power of 3 to cancel out. So I'm just left with 4x plus 8 is equal to 4 to the third power, which is 64. Then I'm going to minus 8 on both sides. So 4x is equal to 56. Then divide by 4. So x is equal to 14. I want to check my solution by plugging in to the original. So the cube root of 4x is going to be 14 plus 8 plus 3 has to equal 7. So 4 times 14 plus 8, 64. And the cube root of 64 is 8. Oh, that is a lie. Cube root of 64 is 4. So 4 plus 3 does equal 7. This is a true statement. So this is the solution.